2 years have passed since NASA's James Webb Space Telescope provided us with an incredible first look at the deepest parts of our universe. This $1 billion telescope serves as the largest and most powerful in space. After capturing stunning images, something remarkable was discovered by the James Webb Telescope, something that NASA had been keeping a secret: Mercury. As a result of this discovery, the mission was quickly halted by the United States. This seemingly ordinary world is far from what it appears to be. Orbiting close to Mercury's blazing heat and our enormous sun, its landscape is dotted with unexpected phenomena, like sparkling diamonds. However, beneath its shimmering surface lies a vast and mysterious element that challenges our past scientific knowledge. What other hidden truths lie behind these amazing revelations? Let's investigate the discoveries that could significantly change our perspective on the planet. Even though Mercury may appear small, don't let its comparison to the Sun fool you. Beneath its intense, boiling surface lies a wealth of astonishing secrets. Recent Earth-based probes have revealed Mercury's shocking reality: diamonds scattered all over its surface. On one of the hottest planets in our solar system, remarkable gems can be found. But this is just the beginning. As we dig deeper, we uncover even more extraordinary findings. Mercury's core is both strange and incredibly large. These discoveries raise significant questions. What distinguishes Mercury from its neighboring planets? What else might it be hiding? The spacecraft Mariner 10 was the first to reach Mercury, making it a pioneer in space exploration. It brought back the first close-up images, revealing a planet with strange features, craters and ridges similar to our Moon. This mission shattered preconceived notions about Mercury's composition, demonstrating that it has a rough surface and a surprisingly strong magnetic field. However, this was not the most shocking revelation. 3 decades later, the Messenger mission arrived, transforming our understanding of Mercury. Unlike Mariner 10, Messenger was designed to orbit Mercury, allowing for comprehensive long-term observations. It recorded nearly 200,000 images, vastly expanding our knowledge of the planet and uncovering previously unseen regions. Messenger's key finding was the discovery of remarkably high levels of calcium and magnesium. This sparked curiosity about the natural processes responsible for these elevated levels. Additionally, scientists were surprised to learn that, unlike other planets in our solar system, Mercury's magnetic field was significantly stronger in its northern hemisphere. These findings forced scientists to reconsider their previous assumptions about Mercury's interior and geological development. Magnetic fields are usually generated by molten iron moving within a planet's core, but Mercury demonstrates a distinct type of magnetic activity due to its unique internal structure. The surface of Mercury is a harsh and unforgiving place. Its craters and ridges endure extreme weather conditions. Daytime temperatures can soar to 860 degrees Fahrenheit, hot enough to melt lead, while nighttime temperatures plummet to -292 degrees Fahrenheit. Mercury's thin atmosphere does little to regulate or retain heat, leading to dramatic temperature fluctuations. However, Mercury's extreme heat isn't its only surprising feature. In 2012, Messenger revealed evidence of past explosive eruptions, contradicting previous theories that Mercury had been geologically inactive for over 1 billion years. Then, in 2020, researchers made yet another fascinating discovery. Mercury's polar regions, which are permanently shadowed, contain water ice. Despite Mercury's close proximity to the Sun, these regions remain cold enough to preserve frozen water. This discovery raised new questions. Could Mercury have supported ancient life in these icy regions? The presence of water ice in such an extreme environment has interesting implications for our understanding of life's potential to survive on other planets. But the story doesn't end there. In 2018, in partnership with the Japan Aerospace Exploration Agency, the European Space Agency launched the Bepi-Colombo spacecraft. Expected to arrive at Mercury in 2025, Bepi-Colombo will provide extensive new data about the planet's surface composition, geological history, and more. Despite Mercury's extreme conditions, its water ice, powerful magnetic field, and geological activity continue to astonish scientists. But here's something even more surprising. On Mercury, a day is longer than a year. We typically think of a planet as taking 1 year to orbit the Sun and 1 day to complete a full rotation on its axis. However, Mercury defies this expectation. It takes 176 Earth days for Mercury to complete 1 full rotation, while it orbits the Sun in just 88 Earth days. This means that a single day on Mercury lasts twice as long as its year. This unique phenomenon creates strange effects. As seen from Mercury's surface, the Sun rises and appears to expand across the sky, only to seemingly pause, retrace its steps, and then continue forward. This unusual motion is due to Mercury's slow rotation combined with its rapid orbit around the Sun. But why does Mercury rotate so slowly? The answer lies in tidal locking. Over billions of years, the Sun's gravitational pull has gradually slowed Mercury's rotation. Today, Mercury is in a 3:2 spin-orbit resonance, meaning it completes 3 rotations on its axis for every 2 orbits around the Sun. This results in its extreme temperature variations. On the side facing the Sun, temperatures reach scorching highs, while the opposite side remains in permanent darkness, preserving frozen landscapes. These wild temperature swings are some of the most extreme in the solar system. As we continue to study Mercury, new discoveries will undoubtedly reshape our understanding of this enigmatic planet. What other secrets might it hold? Only time and future missions will tell. It is essential to keep in mind that Mercury lacks a well-established atmosphere like Earth. Instead, it has an extremely sparse and thin exosphere that continuously vanishes into space, occasionally replenished by radiation from the solar wind and collisions with small space debris. A recent study revealed some unexpected information regarding data from Mercury's exosphere. In 2020, the Messenger spacecraft demonstrated that scientists had previously underestimated the volume of Mercury's water vapor. This water vapor likely forms in the exosphere when oxygen from Mercury's rocks interacts with solar-generated hydrogen. Another amazing feature of Mercury is the speed at which it orbits the Sun, particularly in comparison to its strangely slow rotation about its axis. This combination significantly affects the planet's magnetic properties. Scientists were shocked to discover that Mercury possesses a powerful magnetic field despite its relatively small size and slow rotation. Additional research indicated that Mercury's unique spin, orbit, and specialized movements within its liquid metal core influence its magnetic field. However, it's important to note that Mercury's magnetic field is much weaker than Earth's. While Earth's surface is shielded from the forceful solar wind by its magnetic field, Mercury's thin exosphere offers little protection. Mercury's rapid orbit and slow spin produce extreme conditions on its surface. Some regions, known as hotspots, experience prolonged exposure to the Sun, causing intense heat. Conversely, areas near Mercury's poles remain in constant darkness, allowing ice to persist despite the planet's proximity to the Sun. Mercury's slow rotation and rapid orbit pose challenges for space exploration. Spacecraft must use intricate navigation techniques, including multiple flybys of Venus and Mercury, to slow down enough to enter orbit. The Bepi-Colombo mission, launched in 2018, is currently utilizing these flybys to adjust its speed and trajectory. Once it arrives in 2025, Bepi-Colombo will require careful power and temperature management systems to withstand Mercury's extreme conditions. Mercury's peculiar day-night cycle continues to amaze scientists, providing new insights into its evolution. Studies suggest that Mercury may have once spun faster before gradually slowing down due to the Sun's gravitational pull and potential interactions with other celestial bodies. These discoveries offer valuable information about Mercury's history and the forces shaping its evolution. Despite being the smallest planet in our solar system, Mercury holds many secrets. One of its most remarkable characteristics is its enormous core. According to scientist Dr. Nancy Chabot, Mercury's core accounts for approximately 85% of the planet's total volume, compared to Earth's core, which makes up only about 15% of its total mass. This raises a crucial question. Why does Mercury have such a vast core? One widespread theory suggests that Mercury was once larger but lost much of its outer layers due to a massive collision early in the solar system's history. This giant impact hypothesis, proposes that a large object struck Mercury, stripping away its outer layers and leaving behind the dense, iron-rich core observed today. Despite its weak magnetic field, Mercury remains an intriguing subject of study. Scientists were surprised to discover that, unlike Venus and Mars, Mercury has a global magnetic field. Data from NASA's Messenger spacecraft revealed that Mercury's magnetic field is unevenly distributed. Dr. Katherine Johnson and her team found that Mercury's magnetic field is displaced by approximately 20% from its center, possibly due to changes in the planet's crust and the way heat escapes from its core. In 2020, additional research revealed the presence of volatile materials such as sodium, potassium, and sulfur on Mercury's surface. These findings contribute to the growing body of knowledge about Mercury, making it one of the most exciting planets to study in our solar system. Mercury's mysteries continue to captivate scientists. One particularly intriguing discovery is the presence of water ice in permanently shadowed craters at its poles. Dr. Nancy Chabot's research played a key role in confirming this finding. Despite Mercury's proximity to the Sun, these craters remain extremely cold, allowing ice to persist. Furthermore, the potential presence of complex carbon compounds, similar to those that may have contributed to life on Earth, adds another layer of intrigue. Recent studies suggest that Mercury has experienced more geological activity than previously thought. Although once considered geologically dead for billions of years, data from NASA's Messenger spacecraft indicate recent volcanic activity. Dr. David Rothery of the Open University discovered bright volcanic vents, known as hollows, which provide insight into Mercury's ongoing geological processes. These hollows form when volatile compounds evaporate near the surface, leaving behind depressions. Another peculiar feature of Mercury is its chaotic terrain near the southern pole, first observed during the Mariner 10 mission in the 1970s. Dr. Thomas Waters of the Smithsonian Institution suggests that this landscape was shaped by massive tremors, resembling earthquakes, caused by the Sun's gravitational pull. Mercury's internal structure is equally fascinating. Research led by Dr. Amir Khan of the University of Zurich revealed that Mercury has a large solid inner core, surrounded by a liquid outer core. This structure is similar to Earth's, but Mercury's inner core is significantly larger, which may help explain its unique magnetic properties. These findings challenge our understanding of planetary formation and evolution, demonstrating that many mysteries remain in our solar system. The Messenger mission also discovered that Mercury's mantle is exceptionally thin, measuring only 260 to 420 kilometers thick, much thinner than Earth's mantle. This thin mantle influences Mercury's heat distribution and geological activity. Scientists have also found ancient volcanic deposits beneath Mercury's surface, including large lava plains in the northern hemisphere, likely formed by massive lava flows early in Mercury's history. A 2022 analysis of Messenger data revealed further mysteries, including hints of nitrogen trapped beneath Mercury's surface. This suggests that Mercury may have once had a denser atmosphere, which was later stripped away by the planet's extreme heat and intense solar radiation. Another fascinating discovery involves radiation shielding the ice in Mercury's shadowed craters, allowing it to remain frozen despite the Sun's close proximity. As scientists continue to explore Mercury, new discoveries reshape our understanding of the planet's history, formation, and evolution. The more we learn, the more Mercury challenges our comprehension of planetary science, proving that even the smallest planet in the solar system has a wealth of secrets waiting to be uncovered.